Ahmad dan Rahimu ke atas majlis sesi programming yang diadakan pada hari ini. Berkatilah ia dari awal hingga akhirnya. Ya fa'alu lima yurid. Kami juga memohon perlindungan daripadamu dari segala perkara yang boleh mencacat celakan majlis kami dan daripada segala perkara yang melalaikan kami daripada berbuat taat kepadamu. Kepadamu juga kami serah segala urusan kami. ربنا عليك توكلنا وإليك أنبنا وإليك المصير ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار صلى الله على سيدنا محمد وعلى آله وصحبه وسلم والحمد لله رب العالمين.
Assalamualaikum warahmatullahi wabarakatuh. Morning. Morning guys. Okay.
Morning. Morning.
So uh I much module or in the workshop slide. So I was thinking about maybe you guys, each of you, I want you guys to open up Arduino IDE software so that we can do this together. And any of you can ask question directly. Just unmute and interrupt me immediately. So I will be answering any question on the spot. Okay. So and everybody have download the Arduino IDE and the driver. Anybody got problem for Arduino IDE and the driver? Okay, first of all, if you haven't installed Arduino IDE, you can go to the official arduino.cc website and download the latest Arduino IDE software. Also, you can get the Arduino IDE directly from Microsoft Store. Okay, just go to Microsoft Store and you can just type Arduino IDE. Okay, go to Microsoft Store, type Arduino IDE, and then you just can download it from them. So, okay. The next, the driver. Okay, driver, Arduino driver is used to make the computer to recognize your Arduino board. Okay, by default, Windows and Mac computer didn't recognize Arduino board is what is Arduino board. Okay, when we plug in the Arduino board, it will prompt out unrecognized device detected. So that's why we need the driver. Okay, to make sure to change the setting of our computer to make it recognize the board. Okay, so if any of you guys using you guys seen the slide? Testing. Okay. Do you guys see the slide?
Yes.
Okay. Good. Okay. So start from here. Okay, and anybody didn't install Arduino IDE yet, go to official website, okay, and download. And you can also get directly from Microsoft Store. Okay, Arduino driver. Okay, so I've explained about driver just now. So if any of you using Linux operating system, you didn't need to install any driver because by default, Linux OS already built-in install the driver for any weird things for like Arduino driver, Raspberry Pi, and much more for programming purpose. Okay, so if you want to get the driver, you can go to this link sparks.gogo.co.nz and then slash ch340. You just search this one ch340 Arduino driver. Okay, online. So you can usually this link will pop up at the top of the list. Also, if you accepted as a Jazarian soon, we also have the same driver inside our cloud Google Drive. Okay. Next is basic layout. Okay. So when you open up Arduino IDE, you will be met with this kind of display. Okay. Can you see my Arduino IDE display?
Yes.
Okay. Now, if you open up Arduino IDE, you will be met with this screen with these two functions, void setup and void loop. Okay. First of all, file is here, new file, open recent. And one of most important thing is example. Okay. Any thing that you download like library or new things will be here. It has at least one example. Okay. So if you can see here, example for SP32, the things that I've downloaded is so much. So I just click one of these and then it will pop up a new example for me. So like I can just test my new component. Okay. So and I can create a new coding based on this reference. Okay. So the one that we most use in this example is at the basic and then blink. Okay. This one is very basic that we always use to test the Arduino for the first time. Okay. We click here. So we have this kind of coding here, and you can just straight away upload built-in LED will light up on and off. Okay. So okay, there are many more examples here that just upload straight away and try with your Arduino. Okay. Next we have edit I think comment and uncomment. Okay. So for commenting in Arduino IDE, you can just slash double slash. Okay. The word got gray a little bit. Another one, another type of commenting use slash and star, and then close it with star and slash. Anything inside it. Okay. Whatever I'm talking about, if any of you missed, you can refer back to the module, workshop module that I've been given. It's all the same thing in there, man. So comment is like easier for you, or if you want to pass the program to your friend. So commenting is a very nice way to do so that your friend understand what is this thing, what this function do. Okay. Okay. So if you didn't remember this and you didn't remember this, okay. So for example, you want to comment something. Okay. You want to comment something, you press edit, you highlight this, press edit, and then comment. It automatically comment. Okay. So you want to uncomment, you highlight this, edit, and then uncomment. Okay. So another type of another thing that we use for commenting and uncommenting is to test our code. Okay. For example, you have something here. Okay. You want to test like digital, right? Something here, and then you have analog right here. So this analog right that is something new that you just write, and you don't want to use the digital right, but you also don't want to erase it because you remember how to write it. Okay, like you have one set of code and then you write a new set of code. You want to test, just testing the new set without losing the old set of code. So you just highlight the old set of code, and then you can press edit, press edit or right click, and then comment uncomment. Okay. So like the IDE will ignore this set of code. Okay, and then you test the new code. If the new code work, you can delete it. If the new code didn't work, you delete the new code, and then you highlight the old code and then uncomment back. Okay, so that's about comment and uncomment. Okay, next we have cache. I think cache not to here. Okay, two. Is the most important part for Arduino IDE. Okay, first thing we have libraries here, serial monitor, board, okay, board and programmer. Okay, let me change the board first. So, first thing first, libraries. Okay, just click. If you want to install in the future, some of the component we cannot use simple programming style that I'm going to teach you today. Okay. So what I'm going to teach you today is a simple or the most basic way to program any component. Okay. But some component that you may that you may found in the future, okay, cannot use this style of coding. Okay. So fortunately for your recruitment game, you can 100% use this style of coding. Okay. So so far as I know, for your recruitment game, there's no need to install any additional library and so on, unless you want to do something advanced so you can explore by yourself. Okay. So you just search here the name of the library, choose the latest version, and then install. Okay. So no, you just go to document and then your computer document and then Arduino. Okay. So you will have one folder here, libraries. You just double click and all the library will be in there, the new you install. Okay. Also, if you download external library from Google, you just extract and then put the library in here. So the library should at least have example and script and some other stuff here. So it must be like couple of folder and some file here. So if you want to uninstall a library, so you cannot uninstall from the library manager. You just open this folder and then delete the library you want to delete. Okay, document, this PC, and then document, and then Arduino, and then libraries. Okay, so this is about libraries. Next, we have serial monitor. So serial monitor we can also press from here. So to open serial monitor, you need to currently plug in my Arduino board config. Okay, or something. Okay, so serial monitor and then board. Okay, I've been installing a lot of libraries about another brand of board like it's ESP32 and other this. So for you, your mouse is here, simply output this long list of Arduino. Okay, no, not this small one. Okay, you choose the correct Arduino. So for example, Maker Nano, you use Arduino Nano, and then you see at the bottom right here, Arduino Uno on config. This is mine. It should change to Arduino Nano. Okay, see, it changed to Arduino Nano. And then I'm going to change back to Arduino Uno. So you see here, this is how you want to check of your platform. That's mean my Arduino switch from COM6 to COM4 and then be able to open up this serial monitor perfectly. Okay, so okay. So this is serial monitor and this read inside the then uh, okay, as you can see here, for you okay, anybody can hear me or I'm lagging?
Boleh, boleh.
Boleh?
Tadi lag sikit.
Um, Orang nampak kan ni kan? Boleh tapi okay. So you guys see the okay. So about the programmer, so in in case you forgot to change it back and up. So one other should be bootloader. Okay. So usually we have three last one is help. Okay, so the most best thing about this is the reference. So if you click the reference, you can see the documentation of Arduino language coding full without even using internet. Okay, this reference is offline. Okay, you can open it even you didn't have internet connection, so you can use it to as your reference or anytime to check your error or to explore new things. Okay, so while it's loading, let's get back to the slide. Okay, so that's all the basic about the Arduino IDE layout. So do you guys have any question? Just interrupt me, okay? I will answer directly. Okay, new. Okay, so it's on. Okay. So this is the Arduino reference. You can get the Arduino reference straight away from official website or from the Arduino IDE. Okay. So just now I just pressed the help reference. So this reference is offline reference. As you can see, the address here is the address of my computer inside my folder inside my own laptop. It's not www some kind of address. Okay. So this one is offline. You can open it even you didn't have internet connection. So you can see all the, if you click any of this blue link, it will take you to the another page that will tell you individually about what is this, what is that, how to use this, how to write any of this correctly. Okay. So this is very useful information for you to have a on how to write certain things in Arduino IDE. Okay. Okay. Next, input and output component. So input and output components. There are some things. This is the same as in module or in workshop slide, workshop module. It is the same. So when you deal with components, you have couple of things you need to consider about. So first thing first, it is an input component or an output component. Okay, is the component giving you something, or you are the one who giving the component a thing? Okay, either your component is reading input, or you as the programmer is writing the output into the component. Okay, so this is the first thing, input or output. So this word is important. Okay, input or output with all capital letters. This one is important. Okay, next. So the importance of input and output is you want to use this inside your program. Inside void setup, you need to declare the use of the pin of your component. Okay, so you write pin, pin mode, and then bracket pin number, and then comma, and then roll. As you can see, my capitalization. Okay, so the alphabet here exactly like this. Okay, pin mode with capital M, and then pin number. Pin number is this one is don't care. It's not actually you need to write this word. You just write the pin number. D7, A2, A3, A4, something like that. Okay. So D for digital pins, you didn't need to write the D. Okay. So for D3, you just write 3 here. Okay. For D7, you just write 7 here. But for analog pins, you need to write the A letter here. A2, A3, A4. Okay. So for roll, all capital letter. So you write the roll, input or output. Okay. So pin numbers, for pin numbers, you can use all Arduino pins. Okay, all Arduino pins. And then another one is LED built-in. Okay, inside this, you just pin mode and LED built-in. You just put LED built-in with all capital letter inside here, and it will use the built-in LED inside the Arduino board. Okay, so if you are coding the LED built-in, usually the LED built-in using the same pin as D13. Okay. So if you thinking about using LED built-in in your big project, so you cannot use the D13 pin to any other component. Okay, because D13 is already used for LED built-in. Okay, so you just use LED built-in. That's when you cannot use D13 pin because it's the same pin. Okay, and then you can like I just say, you can use all Arduino pins, digital and analog pins. Next is roll. Roll, you have input pull up, and then output. Okay, so the most common two is input and output with all capital letters. Okay, and then input pull up is a special type of roll. Uh, you just put here. That's mean that we are using the internal pull up resistor. Okay, I think you just need to know how to use these things later. Okay. So for now, just remember that input and output all capital letter inside the row. Okay. Next, you need to consider that either the component is analog or digital. Okay, analog or digital. So what is analog? What is digital? Analog is some component that you give the value or read the value to you, that is given a range of value from a number to a number, like 0 to 255, 0 to 1024, and so on. Okay, so that is analog. If they didn't give the value like that, maybe the thing is measuring something that have a range of value. For example, ultrasonic sensor, we have it is measuring distance cm or meter. Now that is analog also. Okay, so another type of analog is motor power. Okay, you just giving the motor the power from 0 to 255. Okay, that is analog. Okay, next is digital. Okay, what is digital? Digital component. Digital component is the component that you write data or read data, but it is only one or zero, high or low. Okay, if you write the data, you write the output data to the component. Let's say LED. LED, you want to light up the LED, you just put high or low, one or zero. That is digital. Okay. For example, you want to read digital. For example, push button. Okay, you press, it return one. You unpress, it returns zero. Now that is digital. Okay. So how to write output data? Okay, you write output data. So for analog, the value is 0 to 255. You need to write like this, exactly like this. Analog, right, with capital W, and then pin number, the same pin number law that I'm talking just now, and then the value. So the value is should be numeric, okay, not the capital letter or something like that. Should be numeric value. Okay, 0 to 255 only here. So let's say the component it didn't support 0 to 255. Let's say 0 to 1024, something like that. So you need to do a calculation to like uh map the value like 0 to 1024. Let's say 100. Okay, 100 of 1024. What is the value inside between 0 and 255? Okay, you need to do some calculation there. So that you can use the value of the range 0 and 255 inside the value section here. Okay, so this is how you write output data for analog component. And then for digital component, so we have state here. So you write state as high or low with all capital letters, and or you can write 1 or 0 here. Okay, digital write with capital W, pin number, the same pin number as previously, and then the state, high or low, 1 or 0. Okay, next, reading, reading input data. Okay, reading input. So for analog read, for analog, you write like this. Analog read pin number. Just as easy as that. Okay, with capital R. Okay, don't forget this semicolon. Also goes the same from previous slide. Don't forget the semicolon. Okay. So it read values from 0 to 55. Generally, it depends on the component. Okay, if the component is reading 0 to 1024, it will give to you that value 0 and 1024. Okay, don't worry about that. It depends on the component. So for digital read with capital R and then pin number and then semicolon. It read values 1 or 0. Okay, it didn't read value high or low. It's just 1 or 0. That's all. So high or low it will be represent with 1 or 0, and true or false also will represent by 1 or 0. Okay. So this is some common mistakes or error that I think every beginner will encounter this. Okay, so maybe you will be asking your mentors a lot of this type of question. Why my code didn't work? Why it didn't run? Why cannot upload? So at the end, we spot the same mistake, the same error. Okay, so this is the most common that I'm thinking about. So we have three types of error. Compile error. Okay, for compile, let's go back to our IDE. Okay, so IDE here, you can see here these two buttons here. I hope you guys can see. Okay, if you guys cannot see, just tell me. Okay, so this is to verify or to compile. and then this is to upload. Okay, upload the program to your board. Both of these, if I'm not mistaken, you need to have your Arduino board plugged in with to your laptop, so you can use this button. Okay, for this, you just compile the code inside your laptop. Okay, not you not upload it. So for this, you compile and upload at the same time. So we are using this arrow more than this tick. Okay. So for for uploading the code, when you finish write a code, you press this, and then it will start with compile first and then upload. Okay, compile first and then upload. So the error you should see here, you should see here, if it cannot compile, it will see you will see compile error. So if the problem about for upload, it will show compile complete and then cannot upload to the bot. Okay, you need to read the error. Okay, and then another type we have runtime error. Runtime errors is no compile error, no upload error. You can upload. You actually can upload the coding, but the output is not as expected. Okay, you not expect the same output. You expect the different output other than the given output to you. Okay, so that is runtime errors. Okay, so let's make some errors here. So compile error usually about typo, digital. Okay, digital right. So I'm writing digital right here. So if you upload the coding, so you can see here uploading. Okay, compiling sketch first. You see, it compiled the sketch first. So see the progress bar here. Oh no, I think my laptop going to be slow. Okay, let's look at the slide first. Okay, so for compile error, the error that make you cannot compile, usually semicolon. Okay, semicolon, you need to put semicolon at the end of each line of your code. Okay, don't forget the semicolon. But not all end of line need semicolon. Okay, next is bracket. So maybe you have missed the closing bracket, or you didn't put opening bracket, or maybe you just didn't put enough bracket. Okay, bracket inside bracket, but you missed one inside bracket, so it will become errors. Okay, and then typos on built-in function. Okay, built-in function in Arduino is in orange color. Okay, so like I've written here. Okay, so the errors come. You see, digital right usually in orange color, but now it didn't turn orange. Okay, so that means I have done a typo here. So it didn't become orange. That's mean I'm wrong. So you can see here, this one is a compile error. Okay, something not declared, something about this. Okay, so there's no word about uploading here. It's just error. That means this one is compile error. Okay, so it also shows you where the error other than this uh, other than this red line. Sometimes the red line showing the wrong place. Okay, for example, sometimes the red line shows the wrong place. So you can refer to the error here. So you can see this arrow is showing where is your error. Yes, so your error start from digital road. So the thing that you write here. So it show the error is there. So you know where to find. Okay. If I'm not mistaken, we have 9 also. Oh, okay, we didn't have the line number. Okay. So let's make another error. Let's see. right? Or the I can see a tree. Okay, so let's make another error here. So back here. Okay, so bracket, typos, and undeclared variable or functions. Okay. So if you want to use variable or function, and then you forgot to declare it at the beginning of your code, and so that the compile error will pop up like just now. Okay, I wrote digital road just now. It is a function, but it's undeclared. So in the error we saw just now, it from out undeclared variable. Okay, so you need to declare variable, check for semicolon, check for bracket, and then check for typos. Okay, so this is the most common causes of compile errors. Okay, so let's see if the error come. Okay, so now if you can see, I didn't put the semicolon where. Okay, I didn't put the semicolon at B4. Okay, here I should put the semicolon here, but the error is highlighting at the after the semicolon error. Okay, so it didn't highlight this line, instead it highlight this line. Okay, so you need if the semicolon error usually kind of is highlighting something after the error spot. Okay, so because this is just a simple line, so it's just a one line after that mistake. Okay, if you write something like loop or switch or if, then sometimes it will be you put the error is here, but the highlighting is after the loop or after the switch. So it's kind of difficult to spot semicolon error. Okay. You also need to read here. You see, expected initializer before the word serial. So as we know, we want to initialize this. Okay, so you see, it say expected initializer before the word serial. Before the word serial, it expect initialization here. So we put semicolon here. So this line becomes an initialization of variable before. Okay, so that's the error for uh semicolon. Okay, so let's see if I put it correct. Supposedly we can upload the program. So as usual, compile this cache. We will start compile first. Okay, because I want to show to you next error is upload. So compile, you see the progress bar here. If you can compile the code, okay, so the progress bar is full and the compiling is cache. You have successfully compiled the cache, and then you go to uploading phase. Okay, then you have error on the in the uploading phase. Okay, so as far as compiling cache, you didn't have any error. Okay, you didn't have any error here, and it's successfully changed this word to uploading. Okay, that's mean there's no compile error inside your coding. So we just waiting for upload upload error. Okay, we're waiting for the progress bar. Okay, okay. So you see uploading here. Uploading usually faster than compiling. Okay, so uploading and then done uploading. So if your program successfully upload, there should be none thread inside your Arduino IDE. That's mean you're successfully upload the program to the Arduino IDE board. Okay, so let's make some upload errors. Okay, I plug out, I unplug the Arduino Uno board. So now let's see what happened. Okay, so it's uploading. You can, you actually can compile this the program, but you see that is fast. If you can see just now, just a very short time after compiling cache it from uploading here, and then uploading, and then suddenly error. Okay. So this is an upload error. Okay, so you need to wait for the uploading process so that you know your error is compile error or upload error. Okay, so as you can see here, bot at conf4 is not available. So there's no bot at conf4. It is saying that no bot at conf4 because I unplugged my Arduino. Okay, let's look at tools. You see, spot here, we cannot choose anything because nothing has been plugged into. Okay, so let's slide. Usually, upload error is caused by wrong port. Maybe you have multiple port on your laptop and then you put your Arduino board in other ports, but inside the Arduino IDE, you are choosing other ports. So that is making the upload error. Okay, another error is for board error. So you are choosing a wrong board at the Arduino IDE and wrong programmer and also bootloader here. Okay, so you need to check the tools, check the port. I plug in back my Arduino, check port, check board Arduino, and then programmer, and then bootloader. Okay, you just check that thing, make sure the thing is correct. So usually programmer and bootloader, we didn't have to worry too much because if we didn't explore at that place, really it will not change anything. So it's just okay. You just focus on board and port. Okay, make sure the board is correct and make sure the port is correct. Okay, so that is just simple for upload error. So another upload error is driver not installed. Okay, you cannot install, you cannot detect the your board. Okay, so you have plugged in your Arduino but no port coming here. Okay, so that means you need to reinstall the Arduino driver. Okay, just download and reinstall the driver. Next, okay, so this is the set part. So your board, your Arduino board is broken. Okay, you can compile, you plug in, and then it already detect the board is with correct port and so on, but you still cannot upload. Okay, it's successfully compiled, but you cannot upload. So that is because your board is broken. Even though your red LED inside on your board, like Arduino Nano, still on. So when you put you plug in the USB, the red LED will turn on, right? So that doesn't mean your board is 100% healthy. Okay, your board maybe have encountered short circuit or if explode, of course, if the board explode, it didn't light up at all. Okay, so usually short circuit. If you have been connecting 5 volt to ground multiple times, so your board might be broken because you have short circuit it multiple times. So at the end, you cannot upload the program inside it. So there's nothing you can do there. You need to buy a new board. Okay, so be careful with short circuit. Okay, so that's all about upload error. Wrong port, board programmer and bootloader, driver not installed, and broken board. Okay, is there anything to show to you? Okay, so for upload error usually we have something it mentioned board. Okay, it always mention board at conf4, or maybe this one is AVR dude cannot specify something like that. AVR is I think from here from the programmer. Okay, AVR the name of programmer. Okay, so usually the thing like this, AVR or bot, it will say something like this. So that indicate upload error. They know something, know some word such as variable undeclared or something like that. Okay, so this is an upload error, not a compile error. So next we have, let's look this. Okay. So next we have runtime errors. So runtime errors, as I've been talking about just now, we have successfully compiled, we have successfully upload, no errors at all. But the output is not as expected. Okay, we expect something different from the output that given. Okay, so this is because of your programming structure. Okay, so maybe loop and variable misplaced, function and variable misplaced. So what is the meaning of misplaced here? This means you have a loop, you have a function, and then you supposedly to put a variable or function inside something. Okay, you supposedly to put the loop inside a function, you supposedly to put a variable inside the loop, but you accidentally put the variable outside the loop, so that will cause the runtime errors. Okay, so this number 2 and number 3, you need to look at your coding. Okay, runtime errors is like very annoying because it doesn't show to you where's the error, because your writing is correct, no typos at all, just the misplaced. Okay, you just misplaced or wrong or unsuitable structure on how you place things inside your program. Okay, your writing is right, not wrong at all. So you need to watch carefully on loop, on functions, and on variables. Okay, watch carefully. Have you placed it correctly at where it's supposed to be? Okay, so it will correct the runtime error. So runtime error, I think I cannot show to you because I cannot think of any simple one to write the runtime error. Okay. So another thing about runtime error is wrong baud rate. Okay, so this is a common one, baud rate of Arduino IDE. So if you supposedly to show the output on 9600, and then you press here, and then your baud rate by default is 57600. So the output didn't show here, or maybe it will prompt to you question mark, question mark, question mark, or garbage symbol here. So you need to change to the correct baud rate. Okay, 9600. So it will show to you the correct output that it is supposed to show to you. Okay. So now last one is wiring problem. Okay, your coding is correct. No errors, no compiles error, no upload errors. You can successfully upload the coding inside your board, but the output is not as expected. So please check your wiring. Okay, check your wiring. Check especially the wiring for 5 volt and ground. Okay, check the 5 volt and ground, and also check the data pin. Okay, so is it correctly connected, or maybe you misplaced the pin, so you're supposed to connect to pin D4, but you accidentally connect to pin D5. Okay, so please check your wiring. Supposedly this list of error will help you to identify common error or mistakes inside your coding. Okay, so if you have anything to ask, you can just ask me now. Okay, next, for errors, I think that's all. Okay. Okay. Next is common structure. So this is the most common way on how you write the program inside the Arduino IDE. These things that I'm going to show you is using so much, especially in your recruitment game, because you have a lot of LEDs, right? If I'm not mistaken, front lamp, back lamp, signal, and so on. So you might be controlling a lot of uh, input from your Bluetooth, so from your phone. So you might be handling much input, and you might be using a lot of this. Okay, so I think for a single if, we didn't use much. So we only use if else and if else if. Okay. Okay. So this is some error I've been making here. Supposedly else if we have condition bracket here. Okay. So let's make some example. So usually to you write like this. So for example, you already declare. Okay, we assume you already declare all the variable. Okay. So you just if button equals to 1. So you light up an LED. So you light up an LED, digital, right, LED 1 to high. Okay. So next, else if the button equals to 0 or not equal to 1, so digital, right, LED 1 low. Okay. So if the button is pressed, you light up the LED. If the button is unpressed or released, you turn off the LED. So as you can see here, the bracket style, okay, here, the bracket style here, okay, and also the bracket style here, also the semicolon. Okay. As I say, not all end line have semicolon. Okay, and not all bracket after a bracket have semicolon. Okay, for this kind of bracket, it is a function. So when you write a function, you need to put semicolon here. But if you are using this kind of bracket, this is a condition bracket, and it have a block bracket after it. So you you didn't need to put semicolon here. You can write this as this. Okay, you can write like this, but this here you cannot put semicolon here. If you put the semicolon here, it will become a compile error for you. Okay, so usually I write like this. Okay, so it's easy to identify where to put the semicolon. So for closing of curly brace or closing of block brackets, we never put semicolon here. Okay, so this is the most basic way of how you read things and write things. Okay, we didn't read anything yet. So button equals to digital read pin default. Okay, like that. So that's all for things. You just read the pin, read anything to from the pin, and then for button, input it inside a variable, and then use if. Okay, use if to compare the state, and then digital write. You just write the output that you want. So this is the most basic way on how you write your coding. Okay, and don't forget to put the semicolon correctly and the bracket correctly. Okay, for curly bracket, Arduino IDE have auto complete. So if you just if something inside and then you open the curly brace and then you just press enter, so it automatically complete for you the closing curly brace. Okay, so you don't need to worry on how to put this closing brace. Okay, so I think this all for the most basic structure on how you want to write your code from reading data and writing data here. So this example you can see multiple times inside my workshop module. Okay, and on JRW module, I think also have in slide. So you can just refer back if you don't remember how to write this. Okay, so I'm sure that I didn't write 100% same like this, but just you can just refer to the slide, okay, write if condition, and then you can just go back to the slide where how to read or write data, and then just put that thing inside this. Okay. So don't forget to refer to the operator tables on workshop modules. Okay, we have equals to, not equals to, or, and. Okay, so in this here, you can put multiple condition. Okay, so we have if. So let's see. Okay, make sure your bracket style is correct. Let's see if button one is pressed, so equal to 1 at the same time, okay, and button 2 is pressed, button 2 equals to 1, so you do the thing here, okay, you do the thing here. So don't forget to refer to the operator tables inside the workshop module so that you can understand how to use it. Okay, you can have multiple condition here inside this big bracket. Okay, you can have multiple condition here using operator. Okay, and or maybe this operator you maybe more than, small than, equals to, or not equals to. Okay, so make sure to have a look at the table so it will be useful for you to use later. Okay. Okay, so another thing is switch. Okay, so this is the other common structure that you use. We rarely use switch, but for your JRG, we exactly need to use the switch. Okay, for easier for you to write the coding. So this is the basic structure on how to do the switch. Okay, switch, and then the variable. Variable is maybe uh, previous from this switch. You maybe write A equals to analog write or digital write, something like that. And then so case A here. So if A is char, is a character, so you can just put like this with single quote, and then the value is small a and then small b, and then you can write anything here to execute the program. Okay, so let's see some example. Exactly, I will be writing exactly same as this. Okay, you just can refer to this and just can write it by yourself. Okay. On the module, also a detailed explanation about each of these switch and if statement. Okay, so let's write some switch. For example, we have int or int button equals to okay, digital read. So switch. Then okay, another colors of built-in function for Arduino is green. Okay, void loop, switch, setup, if, else. So it's green. You need to clarify. I will not be giving you a sample code on how you want to write a code for RC. Okay, I will not give to you sample code that you just can copy paste and run. I will show to you a structure just like this on how to write things that you can refer later. Then you need to write by yourself, modify by yourself, or combine any of the structures by yourself to make it work. Okay. You can also do some research if you want something advanced or you want to do some other cool stuff that I've not teach you guys. So you can do some research. There's a lot of reference on the Google. Okay. So let's continue. Button, we have int and we have digital. That's mean 1 or 0 only. So because it's int, case, okay, so case also in green color. Okay. Case 1 with a colon, not semicolon. Okay, with a colon, and then you can just put another bracket here, and then you can write if. So now we are talking about the value is 1. That means the button is pressed. So digital right, digital right, digital right, 3D1, 3D1, high. Okay. So next is break. Okay. You can also refer what is the break inside my module. Okay. Case 0. So load. And then case. Okay. Reader write case and write default. Okay. So serial. Okay. Let's say let's assume that we already declared the serial monitor previously. Okay. Uh, invest input. Okay. So just simple like this. So when we talk about INT and digital stuff, we have only two values, 1 or 0. Okay. So let's talk about char. So usually I think digital also or analog, or we maybe use another type of reading. So for Bluetooth, we are using libraries, but that example I will be show to you so you can refer. So we read something inside the data. Okay, the data is taken. We cannot use data to capital data. Okay, capital D. So this is value. Okay. So if we char the variable data of the type char, and then we read the stuff, we put inside the data, and then we check the data value. So because it's char, we use single quote. So let's see F, that means forward. If you press the forward button on your mobile apps, and then it will send the capital F to your Arduino Uno. Okay, so if you press the backward button from your Bluetooth app, then we send B letters to your Arduino. So inside here, you can change to do whatever you want. Okay, either you want to move your robot or turn on the light, anything. Okay, the basic stuff is just the same as this. Okay, these very same things I already put inside the module or the slide. Okay, you can just refer to switch. You can just refer to switch, and then you can just refer to uh, the if statement, and then you just combine them, copy them, and then put inside the switch, something like that. Okay, supposedly if you write everything correctly, you will successfully create your own coding. Okay, so this is the most basic thing on how you want to write the coding for Switch. And if you'll be using you exactly absolutely will be using Switch on your recruitment game, okay, and you also use maybe some if inside your program. Okay, so make sure to ask your mentor if you have any problem. Okay, or you can ask me, PM me on Discord. It's okay. So next, okay, so that's all for the formal structure and how you write a code. So let's have a 5 minute break. You can go to toilet or drink waters or something like that. We stay tuned. 5 minutes. Okay. You can also ask me any question. 5 minutes.